This question is about the use of vector addition for an object at equilibrium. So you are to determine the tension T, its magnitude and its angle, and we should first realize that the whole object is at equilibrium, and we are actually focusing on the ring. If you look at the ring, there are three forces pulling on the ring. Tension force that is towards the top left, another tension force which is by rope B, a 200 Newton force that pulls the ring towards the top right corner, and lastly the third force acting on the ring is a downwards force of 150 Newton pulling the ring downwards. So the sum of these three vectors will get us a resultant force of 0 because the object is stationary, it's not moving, it's at equilibrium. And as usual, I always like to sketch out what are the vectors that I'm adding so that I won't make any mistakes later on. So let's get started on the scale diagram. So first thing, as usual, check that you have written the scale down. And second thing, ensure that when you check your scale diagram, it must be as big as possible because a bigger scale diagram is able to mask the inaccuracies that you have made better. So do these two checks first. Enlarge your scale diagram if you need to, and then we can just start by drawing in the starting point and our very first vector. So I've chosen the downward vector to start, downwards 150 Newton, draw it to scale. According to my scale, it should be 15 cm. I also need to ensure that this vector is vertically downwards, that is parallel to the longer side of a paper. So do this check on your own vector diagram. Next, I will carry on adding the second vector, and I've chosen the tension in rope B to add, that is 200 newtons at an angle of 20 degrees to the horizontal line. So I've constructed a dotted horizontal line, use a protractor to measure 20 degree accurately, and then use a ruler to measure the exact length of the vector according to the scale. And lastly, the tension force, which is the third vector to add, there's only one way to draw because I must end this vector at the starting point. So that is how I can complete the vector diagram, by drawing a vector that ends at the starting point. And once you have done this, you can then measure the length of this vector and convert it to a force according to your scale. You can also easily measure the angle theta, which is the angle that tension force A makes with the horizontal line. And if you have done this accurately, the value of the force should be 204 newtons and the angle is 22 degrees.